today we are to start the application of diode. I am Leeladhar Bhambre, assistant professor in SVIT Chincholi, Nashik. There are two applications of diode. One is the diode used as a switch, and second is diode used as a rectifier. Then first of all we have to study the diode used as a switch. If the diode is connected in forward bias condition, at that time the diode acts as a closed switch, and diode is connected in reverse bias condition, at that time we have to act as an open switch, and hence we use the diode as a switch in open condition and closed condition. In this figure we have to see that if the diode is connected in forward bias means anode is connected to positive and cathode is connected to negative. At that time we can say that the diode is in forward bias condition, means diode is in on condition and it acts as a closed switch. In the second figure we have to see that the diode is connected in reverse bias condition. That means the anode is connected to negative and cathode is connected to positive, and then we can say that the diode is in reverse bias condition. At that time the diode acts as a open switch. Hence we can say that in forward bias condition the diode acts as a closed switch, in reverse bias condition the diode acts as a open switch. Then second application of the diode is a rectifier. Rectifier means it converts AC circuit into a pulsating DC. This is the main application of the diode. There are three types of rectifier. One is the half wave rectifier, second is the full wave rectifier, and third one is a full wave bridge rectifier. The full wave rectifier is divided into two types. One is the full wave center tap rectifier and second is a full wave bridge rectifier. Okay, then we can see the one by one. First of all we have to study the half wave rectifier. This is a circuit diagram of the half wave rectifier. In half wave rectifier we have to use only one diode. The diode is connected in forward bias condition, means positive terminal anode is connected to positive and cathode is connected to negative, and in between the load resistor RL is connected. The operation of a half wave rectifier is in first positive half cycle the diode is in the forward bias condition. That means it is an on condition and current can be flowing through the diode take place, means the one single half cycle we can obtain at the forward bias condition. And if in the second half cycle, negative half cycle, at that time diode is in reverse bias condition and no cycle will be obtained at the output side. Only in half wave rectifier only positive half cycle will be rectified, and hence it is called as a half wave rectifier. Okay, please see here, this is the input cycle. This is the input cycle, this is the positive cycle, this one is the negative cycle. If positive cycle going to the diode or given to the diode, at that time diode is in a forward bias condition, means it is a on switch, and we have to give the same positive half cycle at the output side at the load resistor RL. If diode is given to the negative half cycle, at that time the diode is in reverse bias condition and it acts as a open switch and no output will be available at the negative half cycle. That means total full cycle will be given to the input side, but only one single cycle will be rectified, and then it is called as a half wave rectifier. Second is the center tap full wave rectifier. Why it is called as a center tap? Because the center of the secondary of the transformer will be tapped, means the transformer contains three terminal at the secondary winding, and this is called as a center tap rectifier. Please see here, this is the figure. This is the transformer, this is the transformer, this is the primary winding, input is given to the AC voltage to the primary winding, output is given to the secondary winding. You have to see that in secondary winding there are three terminals. This is the, suppose we have to consider this is the A terminal, this is B terminal, and this one is the C terminal. It has a three terminal, means center of the transformer will be tapped. This is called as a full wave center tap rectifier. In full wave center tap rectifier we have to use a two diode D1 and D2, and in between we have to connect the load resistor RL. First of all we have to see the construction of this diagram. Okay, above figure shows the center tap rectifier. In this rectifier special types of diodes such as center tap a transformer is used. In this rectifier we have to use the two diodes D1 and D2, okay, are connected in as shown in this figure. Then we have to study the operation of this center tap rectifier. In first positive half cycle, the diode D1 is in forward bias condition. At that time, the diode D2 is in a reverse bias condition. Means the current can be flowing through only D1 and then through the load. In second negative half cycle, the diode D2 is in forward bias condition. At that time, the diode D1 is in reverse bias condition and the current can be flowing through the diode D2 through the load. Means in first positive half cycle we have to get the first positive half cycle. In second negative half cycle we have to get the second half cycle, and then total cycle will be rectifier, and this is called as a full wave rectifier. But we have to use the center tap rectifier, and then this is called as a full wave center tap rectifier. And then next is a bridge rectifier. In bridge rectifier we have to use a 4 diode. No need of special purpose of transformer in this rectifier. Just only simple 2 terminal or secondary contain only 2 terminal transformer is used. In 4 diode we have to use the 4 diode D1, D2, D3 and D4. 4 diode are connected in a bridge manner. This is called as a full wave bridge rectifier. We see here how to connect the diode. We see here at the transformer secondary winding, the diode D3 cathode and diode D1 anode are combined together and connected to the transformer winding, and second terminal of transformer is diode D2 and diode D4. Diode D2 is a cathode terminal and diode D1 is an anode terminal, combined together and connected to the second terminal of the transformer. Means we can say that first diode contain anode, second diode contain cathode. They are combined to each other and connected to first terminal of the transformer, and second 2 diode are considered as D2 and D4. The second the D2 contain cathode and D4 contain anode. Both are combined to each other and connected to the second terminal of the transformer. And we have to in between, this is anode connected to 2 diodes and cathode connected to 2 diodes. In between this we have to connect the load resistor. Then we have to see the operation of this bridge wave rectifier. In first positive half cycle, the diode first positive half cycle going to the diode D1 means positive supply given to the D1. At that time the D1 is in forward bias condition and the current can be flowing to D1 through load resistor RL, and D2 means opposite direction of diode are in forward bias condition, and current path will be D1 to RL, RL to D2 and second terminal of the transformer. This is the first positive half cycle. In second negative half